Have you ever really stopped to think about how that thick, black gunk they pull out of the ground, crude oil, turns into the fuel that powers, well, everything? It seems so simple, but it's actually one of the most complex chemical puzzles out there. So let's follow that wild journey from the oil well to the gas tank and really unpack the incredible science of petroleum refining.
Here's how we're going to break it down. First, we'll get a handle on what petroleum actually is. Then, we'll dive into how refineries tackle the huge job of sorting that messy mixture. From there, we'll check out the game-changing piece of tech that made all this possible on a massive scale. And to finish up, we'll get into the really wild stuff, how scientists can literally break molecules apart in a process called cracking.
All right, first things first. You can't understand the journey if you don't understand what you're starting with. So, before we get into the nuts and bolts of refining, we have to ask the most basic question. What even is petroleum?
You know, it's really easy to think of crude oil as just one thing, but it's not even close. It's actually a jumbled cocktail of all sorts of different molecules, mostly these things called hydrocarbons. Just picture chains of hydrogen and carbon atoms, but in all different shapes and sizes, all mixed up together. It's less like a pure liquid and way more like a very, very complicated soup.
And that, right there, is the whole challenge of refining. In its raw, crude form, this molecular soup is, well, it's pretty much useless. You definitely can't just pump it straight into your car's engine. So, to unlock all the energy trapped inside, we have to find a way to sort through that entire mess and pull out all the valuable bits we actually need.
Okay, so this brings us to the first giant step in any refinery, separation. Seriously, think of it like a massive sorting facility. But instead of packages, it's sorting individual molecules. The whole goal is to take that chaotic gunk and neatly organize it into much more useful groups.
So how did they do it? The main trick is a process called fractional distillation, and it all works on a surprisingly simple principle. Smaller, lighter molecules boil at lower temperatures than the big, heavy ones. It's kind of like if you had a pot of different liquids. If you heat it just right, you can boil them off and collect them one by one. And here's the key thing. At this point, we're not changing the molecules at all. We're just sorting them.
And what do we get out of this first big sort? A whole bunch of stuff you definitely recognize. The lightest bits, or fractions, give us things like petrol or gasoline. The next level down gives you aviation fuel and kerosene. Go a little heavier and you get diesel oil. And the really heavy stuff? That becomes lubricants. Each one is a specific cut from that original crude oil.
But okay, it's one thing to understand the science. It's another thing to do this on an industrial scale, for millions of barrels of oil a day. That takes a seriously impressive piece of engineering. A technology that didn't just improve the process, it completely changed everything.
And that is not an overstatement. The pipe still is literally the heart of a modern refinery. Before this thing came along, distillation was done in these slow, inefficient batches. The pipe still's genius is that it works continuously, and that continuous flow is what made the mass production of fuel possible, and, honestly, changed the world.
So how does this amazing machine even work? Well, picture this. First, the crude oil gets pumped through a maze of pipes inside a huge furnace. It gets heated up incredibly fast until it's a mix of liquid and vapor. Then, the superheated mix gets shot into a giant, tall tower, the fractioning plant. As all that vapor starts to rise up the tower, it begins to cool. The heaviest molecules turn back into liquid first, way down at the bottom. The lighter ones, they keep floating up until they too cool down and condense on trays much higher up. It's this beautiful, continuous dance of sorting by temperature.
But what if you need more gasoline than what you can get from just sorting? You know, what if the world wants way more petrol than a barrel of crude oil naturally has in it? Well, that's when chemists go to the next level. We move beyond just separating molecules, and we start to fundamentally change them.
This next step is called cracking, and the name is absolutely perfect. Refineries literally take these long, heavy, not so valuable hydrocarbon molecules, and using insane amounts of heat and pressure, they just break them. They crack them apart into the smaller, lighter, and much more valuable molecules that we use for things like petrol.
And just how do you crack a molecule? With a whole lot of heat. We are talking about blasting these things with temperatures around 550 degrees Celsius. To put that in perspective, that's hot enough to melt lead. This crazy amount of energy makes the molecules vibrate so violently that their carbon bonds just snap.
The result is a complete transformation. You start with these big, clunky molecules that you find in the heavier oils, but after cracking, you've got a whole new batch of these smaller, nimbler molecules. Exactly the kind you need for high-demand fuels, like petrol. It's like turning boulders into pebbles.
And it gets even more advanced. There's a special version called catalytic cracking. Basically, by adding a catalyst, something that helps the reaction happen more easily, refineries can get even better at turning those heavy oils into higher octane petrol. You know that high octane number you see at the pump? Well, this process right here is how they achieve that higher performance.
So there you have it. From a chaotic, messy soup of hydrocarbons to precisely engineered fuels, the journey of oil refining is just an incredible feat of chemistry and physics happening on a mind-boggling scale. It really makes you wonder, what other everyday things that we take for granted are way more complex than they seem?